Okay, welcome. We're going to be doing a little bit of what we did last week. I mentioned this before. My last recording had some mistakes on it, so I'm going to review some of the commands that we went over last week or on Monday. That's going to include extrude, extrude from a curve to develop a surface. We're going to do sweep. We're going to do lofts, and we're going to project lines onto surfaces. At the end, I am going to go through, and you guys can just watch me. I'm going to go through how to export your drawing to Adobe Illustrator and create a drawing. One of the things that I'd like for all of you to have next week, and you can submit it in Module 1, is a drawing of your project. So it's just going to be line work, and you guys can add some color. I'm looking for black and white drawings. But I'm going to show you guys specifically how to customize your strokes, which is the line weight in Illustrator, and then how to control your fills using a command called make live. It's really important. If you guys run into this issue, I'll repeat this later. If you run into issues in Illustrator with make live, it's because your lines aren't touching, like actually touching. It looks like they are, but they're not. And that's why it's important to use your O snaps when you're in Rhino. Okay. If you do have any questions during class, just drop them in the Module 1 folder with the specific questions that you have using the document. Okay, so last class, I went over how to make curves. And so I'm just going to show you guys, and some of this might sound repetitive. That's a polyline. I'm going to do a polyline with a degree 3 curve. If I select the line, I can type extrude curve. And now I can select how far I want to extrude. That's going to generate a surface. A lot of you, when you're doing your line work, that's how you're gonna, or you're doing your sections, that's how you're gonna generate your 3D model. So I'll do the same thing here, extrude. And one of the tricks that I showed you guys last week is how to get a single line that generates the profile of your building. And that's using the curved Boolean. So just to show you a quick, simple example, if I have 2 squares, I can use a curved Boolean. So I type in curved Boolean, select the 2 curves that I want a Boolean. If I tell it not to combine regions no, then I can click inside and generate 3 different boxes off of these squares. If I do the same thing, curved Boolean, combine region yes, I select these 2, click, 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 and I pull this out, it Booleans them so that it combines the different regions. Some of you might be running into this problem. I already heard someone ask this. Even though I have a line and it looks like it's going to separate it, if I do curve boolean, doesn't matter if it's combined region or not. I'm going to select all of these. If I click in here and I click through, it treats it as one because it's not truly closed. So when I click and I click again, it just selects it and deselects it.
What
So-
happens if you click the top one?
Here?
Yeah. See, my issue is I was hitting one that's like that one, and I would try to hit that one, and it would like turn it off. Is that because they weren't close?
Because this is what's happening. So what you're doing is you're clicking over here and saying that's a box, and then clicking over here and saying that's a box, and it's the same box. It's the same box because it's not truly closed. So look for the line that looks like it should be separating the spaces. If I extend this over and I try to do the curve boolean now, it'll treat it as two. Everybody got that? Curve boolean. So the trick that I showed last week, which I'll repeat, if you're noticing, there are guidelines that show up with Rhino. I was able to make a box using the edges of these curves by just hovering over them. So if I show this again, I want to make a box and I want to go to the edge of this line. I can just hover over this point. A gray dot will show up. Now I can just scroll up and it's going to lock to that point. So I can start here and it's going to be to the edge of that line. If I want to go to the other edge over here, just hover over it and I scroll down and now I have a perfect box around those lines. If I were to do curve boolean now, if you guys watch up here, this is a better example. If I do curve boolean, I select everything and I hit enter. What I did last week, I was able to click and I right away got the profile of the building. But I have now the ground is dividing my building. So I have to make sure that the combine is yes. If I do combine no, I'm going to click up here and get a profile. I'm going to click down here and get a profile. And it's going to be two different profiles, which could be great, let's say, if I want to hatch the ground. I just got the ground. Awesome. But if I want to get the profile of the building like I did last week, curve boolean, I'm going to make sure combine is yes. I'm going to click on both sides since that line is dividing the building. When I move it out, now I have the profile. I don't have to move it out, but I'm showing you guys so you see it. Does that make sense? Does it not make sense to anybody?
Do you use the square?
Huh?
Do you use the square?
Yeah. When I export this to Illustrator, I'm going to use the square to color in. So you don't have to. You can use it. You can draw a square in Illustrator later on, and just use the sheet as your square. But I'll be exporting this. I probably won't use it, but okay. So the command that I wanted to show you is extrude to start off. So I'm going to take the profile of the building that I already generated, and I'm going to extrude the distance that I need. Now I have a floor plan in here. This is my floor plan. Actually, that's not my floor plan. Let's see. I'm gonna try to align my plan and sections together. So they're not exact. Scale. So this isn't exactly the size I need it to be so that they match. What I'm gonna do is I'm gonna scale my plan down slightly because it's a little bigger than what my section is showing. So to do that, I'm going to type in scale. I'm going to use this reference point, and I'm going to go to the extent of that floor plan and use it as a reference to bring that back down so that it matches. So now they're the same. And what I'd like to show is just different ways that you can extrude surfaces. This isn't going to be useful maybe for everyone, and if it is useful for anyone, it might not be useful for the entire project. But you can use this for your plans or your sections. You have to choose what's going to be the best command for whatever detail it is that you're trying to model. So I'm going to try to go through different commands. The extrude, pretty straightforward. You take the line. I'm going to take the profile of the building, and I can extrude it to generate the profile of the building in 3D. Now this doesn't match what my model looks like, but that's one version if I wanted to generate something that looks similar to this. Let's say I have stairs, and let's say I wanted to generate those stairs. If you look over here, I'm not going to be able to extrude these because the stairs don't extrude in this direction, but I will be able to extrude these here. This might be useful for a lot of you, since I'm going to guess that everyone has stairs. I just drew a section of the stair. I'm going to extrude this. Typically, stairs are going to be at least 36 inches. If it's a fire stair, it's probably going to be wider than that. That depends on the load of the building. Don't worry about that. So for now, I'm just going to extrude these 4 feet. And now I have the staircase. Everybody see that? I can use, if you guys are aware of the fact that even though these stairs, this is a drawing of the stair in elevation, this is a drawing of the stair in section. These steps should all be the same height to each other. So if you're clicking one by one, and they're a different height, it's not going to look good. So I'll show you what I did. Is I drew one section of the stair and I copied it over. Does that make sense? So here's what I did. Rather than let me do it up here. Yeah. So what I did is I drew just one section of the steps that looks like this. Looks like an L. And then all I did is I copied it over. Until I got to the height that I needed. And then I drew the next line. And at the end here, I drew another line. Right? How did I determine the heights for these? I'm working in section. How did I determine the heights for these? Is I did a copy. And I just used this as a reference. So now they're the same. The distance between this step and this step is the same distance between this step and this step. And now what I could do is use it as a reference to copy these all the way through. You guys follow? Why does that matter? I'm just going to copy this over. By the way, all my floors are exactly the same. And that's important to you. If your floors are supposed to be exactly the same, you can just copy the information from floor to floor. So in order, these are all segmented because I drew them in segments. I can type in join. So now they're one. And I'll extrude these 4 feet to get that. How do I get this other section? Is if it's coming down in this direction, I'll copy, and I'm going to assume that this point here is that point in elevation, and I'll just rotate. That way. Yeah? So one thing that I was able to get from this that I wasn't able to get from this is the width of that stair. So I can just delete that. I'm going to scale 1D from the width of the stair and lock it to the width of the drawing, and now it matches. So if I wanted to, now I can drag this back over, rotate. Now I have my stair as it's coming up. To build this surface, I go to the side here, hold and click. I'm going to go from corner to corner. So corner to corner. Everybody get that? Another way, just to show you guys that there's different ways of drawing squared surfaces. I went from corner to corner. This time I'm going to go from edge to edge, and I'm going to define the length. Yeah, so sometimes you don't have the other corner, but you have one edge. So you can just use that, and you can use different ways to develop a surface. And in theory, this should just drop in here until it gets me to the height of that floor. Yeah. And what I'm going to do is I'm going to do a copy vertical. So vertical is set to no, so it lets me copy anywhere. But if I restrain it to just vertical, now I can click from the top of the floor plate, top of the floor plate, top of the floor plate, until I get the entire core. If I go to my front view, since I got one of the drawings right, all the drawings are right. They're all the same. That makes sense? That's why it's important to just make sure that you're consistent with how you're doing one floor. If they're all the same, you can just copy things over. And this one you can't see because it's in there. It's shown in the line. Okay. Is that helpful? Everybody has cores, so at least now you guys know how to model a stair core. So I'm going into my C plane, and I'm going to show you how to sweep. Sweep is useful if you have a wall that's not extruding. It's not extruding in a straight line. So Lulu, you have this condition in one of your floor plans. So this is what I want to show you guys. If you look at the drawing that I just made here, the top view is basically showing that I have two objects and then I have two lines. And extrude looks like this. I can select that, type extrude, and it's going to extrude it in a straight line, right? It's going to extrude it perpendicular to how that line was made, which is perpendicular to that construction plane. If I were to extrude this, it's not going to go along the line, right? That makes sense. So how do I get this thing to extrude along the line? One way you can do that is by using the command called sweep. So if this was your wall section, and along the floor plan, rather than going straight, it's going at an angle, what I'm going to do is I'm going to type sweep 1. Sweep 1 means 1 rail. Sweep 2 means 2 rails. And I'll show you the difference for that as well. I'll show you the difference between sweep 1 and sweep 2. So sweep 1, the first thing it asks me is select your rail. That's going to be the line that it follows, just like a train, right? What lines do you want? I'm going to select that one. Right away, since it's only sweep 1 and you're selecting one curve, it doesn't ask you to hit enter. It goes straight into the next question, which is select your cross section of the curve. Now I'm going to select that wall. So I'm going to click it, hit enter. It's going to ask me to adjust the seam. Right now it doesn't matter, but if you're doing multiples, it might matter. And the seam is basically defined by that point where the arrow is. So I'm going to hit enter. And now you can see that that curve is following the line. That's sweep 1. I'm going to show you another one. Okay. Right. Okay, I just moved my C plane because I wasn't drawing on this on the same C plane or construction plane. I just want to show you if you had. Damn it! What's going on? So I'm going to just project this as a C plane. I don't know why it's doing that. I'll find out. I'll find out in a minute. C plane. Yes. Okay. So now I have that flat line. Well, I don't know what's going on. Okay. So I showed you a straight line and how you can sweep that. I'm going to sweep, same thing. Sweep 1, select the rail, select the cross section. And same thing, it follows the curve. So if you have a wall that's making turns, and the floor plan defines where the turns are of that wall, you can draw the direction of the wall. So that's sweep one. Sweep two, what does that mean? It basically takes two lines into consideration instead of just one. So sweep two, first rail, second rail. Now the cross, enter. And if I look at it now, I don't know why it went up. But what you can see is that this thing changed also in width. So the cross section of the wall changed. Okay, I don't know, I've never seen that before. It shot it up and I don't know why. So I'm just gonna tell it to maintain the height. And so now you can see that I did the same thing. You saw that I had the same component, just two different rails, and it basically followed those two curves. Okay.
What if you want a slanted wall?
A what? A slanted wall? Sure. Okay, so the question is, what if I wanted a slanted wall? Well, if it's a slanted wall, it wouldn't look like this. So I'm gonna slant this by selecting those 2 points and move it over. So in section, it looks like this now. So before I extruded this or swept this, now I have a wall that's curved or at an angle. So it's the same thing, sweep. Select the rail, select the cross, enter, enter, and there you have it. Because I remember specifically one of the other situations that you have for this is that there's a door opening in there, and the question is how do you get that door opening? Yeah, okay. So I'm going to show you guys how to make a door opening for that.
Can you do this slanted wall from the floor plan, or you need to do it from this
The slanted wall from the
floor plan, like extruding from something that is there?
yeah, I mean, so one of the things also, guys, is that you should be careful with, again, because I saw your model, is if you're drawing a wall, even though in real life walls are not really parallel to each other, when we draw them, they're parallel to each other. So what I can't do is go to the top view here, draw the outside of the wall, and then separately draw the inside of the wall and say, oh, that's close enough. It's not going to be close enough. Trust me, no matter what, it's not going to be close enough. So you have two options that, in my opinion, are going to be simple. One is to just copy the line. That's going to give you a parallel condition, right? That's consistent throughout the whole thing because it's the same line. The other thing that you can do is you can offset it. So you can select the line, type offset. My distance is set to 8. If you're looking at the floor plan and it's not perfect or it doesn't look right, you can change it. My distance is set to 8, I can make it 9. I can make it 10. I can make it 12. I can make it 2. Right? So you guys can determine that when you look at your floor plan. What I would rather than knowing that it's 8 inches and you actually drew it at 9, I don't care. What I'd rather know is that it's parallel. Right? So you got it wrong by 1 inch. I don't care. It's parallel. I care about that. And it's not that I care, it's just gonna make your life easier when you guys are modeling. So the question, if I'm correct, is that how do you generate that wall from the floor plan? Is that right? Okay. What I could do is, I'll show you another command, which is Loft, which I wanted to go over. If I know that this is the section of my wall, and I know that this is the plan of my wall, what I can do is I can define that wall by copying the base over to the top, and I can do Loft. So I'm going to type in Loft, select the curves to Loft. I want the top, and I want the bottom. Now remember, it's really important, Rhino is specific about where you click. So I make sure I click on the same side, same edge, that I want this thing to loft in. If I click this line here, and then I click back here, it's not gonna show up right. So I'm gonna click on this side, enter. This is where it's important about the seams. Because I clicked on the same points, the seams are consistent. If I were to click on the outside and then on the inside, you see how they're different now? So when I loft them, you see how it's all twisted? Because I clicked on the wrong points. I can correct that. I'm gonna do it wrong. So I did outside to inside. I can correct that by just moving this over. I clicked it and I drag it back in. So now they're consistent. I can hit enter and now it looks like a wall, normal wall. Does that make sense? Okay, plus I also got my wall. Is that helpful?
Yeah, do you need to draw, because when you're cutting a wall that is slanted, you can see the line that it touches the floor, right? Like the elevator. Like you have the section cut,
Oh yeah, huh?
and then you can see this line right by it.
Yes.
Do you have to draw it?
Well, what I would do is I would draw the cut, and then I'd place it where the plan shows it touches the ground, and I'd loft it from there. Does that make sense?
Yes. So you don't really need to trace it, you just need it for reference.
Yeah. That we're using as reference. This doesn't have a surface at the end. It probably doesn't matter because there's going to be a floor plate, but I can just cap it, and it's going to close it. Yeah. The other thing that I could do, and I'm just going to show you several ways that you can do this, is I can do the same thing. I can sweep one. I'll click on the rail. I'll click on the cross section, enter, and I just did the same thing inverse. Okay, hopefully that's just in the recording if you're missing it. Okay, I'm gonna hide this, and I'm just gonna make up that in floor plan. There's a 4-foot door opening, right? So Lulu, I know you have this condition. There's a 4-foot door opening. It's only showing up in plan. It's not at the top, but here's my reference point for that. Trying to think of what's going to be the best way to. So what you could do, the doors are usually going to be vertical. And so what I would do is I would find this point, and I'd find it up here, perpendicular, just to define the extents. Yeah, just copy it over. And this is the way I like to do it, and again, I'm just going to show you several ways. So I'm gonna make a box that shows up as a door, and then I'm gonna boolean it out. Yeah. And so I can do curve boolean for that section in there. So now I have a box. I can extrude this, and I'll assume it's 8 feet. I can delete that box because that square. I don't need it anymore. I'm gonna scale 1D because it's at an angle. I need this to be wider, much wider, so I can boolean it out. And so what I'm gonna do is I'm gonna scale 1D from the middle, not from the edge, from the middle. And I'm just gonna expand it like this. What that's gonna do is now it's gonna pierce that surface, right? So this is gonna be the place of the door, and all I'm gonna do is I'm gonna boolean delete now. So I'm gonna go to boolean difference. It's gonna ask select the surface to subtract from. It's that curved wall. Enter. Select the surface or poly surface to subtract with. It's gonna be this box that I made. Enter. And now I have the door open. Got it? Cool. Yeah. So it's different than trim. You can do trim. So I'm going to type in trim, select the cutting objects. It's this one. And then enter. And then it's going to ask me to select the objects to trim. If I click on the outside and say this one, it's going to get rid of it. Because I just clicked on the side, on the surface that I want. And what it did was it gave me the inside. It's not what I want. So that's why it was more convenient to do Boolean. But just to show you guys more examples. I'm going to try to get in there. Right now I can't get in there. At least it's not easy. So one of the things that I suggest is out here, the lens length. I'm going to widen this up. You guys have heard of like a fisheye lens on a camera. It's a wide angle lens. So right now it's 50, which is how the human eye experiences the world. If I make this wider, 15, it's going to distort it. Things look sometimes kind of cool when they're really not in this angle. You can render in this angle. You can make 2D in this angle. I wouldn't recommend it. By the way, did I go over parallel and perspective views? No? Okay, I'm going to take advantage now. I think I did. I did.
In the workshop.
In the workshop. Okay, fine. Well, this is a vertical line. At least it should be. Doesn't look vertical anywhere. Except maybe when I go far away. But do you see how that wall doesn't look vertical at all? And when I take it to the edge, you see this little triangle here? But this is vertical. It's a distorted view because my angle, the length of the lens is so wide. That's because I went down, I decreased it. If I want to make things true, use the parallel view. And I'm just going to show you guys, that's a true vertical, right? And when I scroll it over, you can see that it aligns to the edge of my viewport. I'm going to go back to perspective. You can, at 50, it's going to be a little bit better. At 200, it's going to be really close. So you're still in perspective view, but it distorts it less. Anyways, back to the point, which is I'm trying to get in there. if I use the wider angle, I can get inside of this a little bit easier. So in order to get in there, your pivot point for when you're orbiting changes as you zoom. So what I'll do is I'm going to zoom in, Z, enter. I'm just going to zoom into this area. And now when I pivot, I can get inside. So I'm just going to show you guys trim, same command, trim. This is my cutting object, the box that I made for the door. Enter. Select the objects to trim. I got to get in there, inside of this thing.
What?
Now that I'm in,
I'm sorry, I was just gonna say, what can you just use,
Explode.
What?
Explode.
no, well, just to get inside, change the view to. the-
like ghosted.
Yeah,
Yeah, sometimes that works if you have a lot of things, it won't work. And also if you have multiple surfaces and you click from the outside, it looks like you clicked on the inside.
but
There's a way around it because you can click on the ISO curve. So yeah, that's a good point. I can click on the ISO curve and do that, but it can get confusing. So I'm trying to take
all the
advantage of
time.
just showing you guys different things that you can do here.
Okay.
So yeah, you can definitely try doing that. And again, you guys should explore on your own things like that. So I'm just gonna go inside. I'm gonna click. I think I have to click again. I don't think I did, but okay. So it looks like I didn't do anything, but what I have now is an opening inside, and you can see that I didn't trim that. So you can see that Boolean off the same object. Boolean was just easier. But sometimes if you're like if this surface wasn't there, this wouldn't be a solid object, and Boolean might not work. And sometimes you have conditions like that where you'll have to trim. So trim will work on something like that if it's open. If it's closed, which I knew it was, Boolean was going to work. So I'll just do it again. Difference. To subtract from, enter. Subtract with, enter. And then it's the opening. Lulu, is that helpful? Because I know you had that as a question. Okay. I'm going to show you a basic example here. Fuck, is it 10:15 already? All right, this is what I'm gonna do. I don't have time to go over the Illustrator stuff. I'm gonna do a recording. I want you guys to do it. I haven't set any deadlines, and this class has been pushed to the back. I'm setting a deadline though for this drawing on Monday. It's really easy. It's not gonna take all day. It's fun, and it's gonna come out nice.
Mhm.
So I'm gonna show you guys through the drawing that I have here, which you all should have a drawing similar to this. How you can make a drawing off of this in Illustrator, and using Make Live, you guys can add colors. So I'm gonna do a little video. I'll send you guys a notice when it's up. It'll be on YouTube. It'll be on my website, so you guys can watch it. It'll probably take about 15 minutes to watch it, and maybe 30 minutes for you guys to do it. Twice as long, because you guys are slow. Okay, so I'm gonna show you something else. There's the project that you have, right?
Yeah.
So
What file did you want me to upload it to in the drive? Like which folder?
the module 1 questions.
Okay.
So I'm gonna do a basic version first, and then I'm gonna do real quick your project if I can get it open. This command is called Loft. We went over project last time too. Are you okay with that? With project? Okay. So I'm gonna do Loft, and I know that for that building, there's a belly underneath that has a curve, and at the top, it's just a flat surface. So the thing is that it's not a simple extrusion, it's moving like this,
Yeah.
right? And so what you would do is, if you see that you have a surface that moves around like that, you're gonna loft between the different sections.
Right. Okay.
So what I would do is I would say, let's say they all start at this point. And just so that there's difference, I'm just gonna randomly. Click along, right? Got it. Now, these aren't random lines. These are moments on that surface that exist. And what you should do is find those moments
Yeah.
in space where they happen. And I should have brought. Oh, crap. Okay. So I'm just going to copy that over. So I need multiple copies. I need to really sloppy this. Since I copied it over, I'm going to delete that. So I have 3 different conditions, and I'm going to use that to define my surface. What I can do now is I can loft between these curves. So I'll type loft, select curves to loft, 1, 2, 3. Again, if I click on these ends, if I go from here to that end, it's going to be messed up. I'm going to hit enter, and then you get a surface. I look at it from the front view. That surface actually follows the geometry that I defined.
What's the difference between that and network surface?
Network surface?
Yeah.
Network surface has an additional curve as a cross section that you're referring to.
Yeah.
If you need it to be more constrained and you have that information, I don't know if you have that information.
No, I don't. I just don't know what the difference between like locking those curves or like network.
Yeah, well, with loft, I mean, still like I can. So there's different. If you look at the lines, look at the ISO curves. I can loft between these, and it's going to change a little bit, and you're not going to have full control over that. I would say that for this assignment, you shouldn't really need to worry about that.
Okay.
Network surface is just a different way to develop a 3-dimensional surface when you have cross-sectional information.
Okay.
That's going to be kind of hard for this.
Okay.
So I wouldn't worry about that for now. For now, for this project, you can develop it like this. So for those of you that have this project, was that helpful?
Yeah.
Does that help? And you can determine where it's located based on the plan.
Okay.
Or a section in the other direction.
Right. Okay.
So you might actually have, if you have a section in the other direction, points that you can use as a different cross-section curve and do a network surface. They can generate the same thing and just have 2 different ways. Just like I showed you how to get an angle wall by sweeping or by curving or by lofting, it's the same thing. Just different ways to get the same thing.
Okay.
Yeah. Okay. Any questions? You guys are good? Did I cover most of everything that we went over last time? The only thing that we didn't cover was project, and I'm going to cover that on the next class.
And you. We did that last class, didn't we?
We did.
Projected it to a solid.
Yeah, projected